A great talk by Ignacio. I'm trying to follow and do justice as well. So from Lawrence Berkeley National Lab in Berkeley, California, we're going to be talking about how we are bringing 5G networks for science. So I work as part of the DOE, which is the Department of Energy Labs, which is LBNL, and that's why we're talking about science here. So just to introduce everyone to what ESNet is. So for example, whenever the Large Hadron Collider runs in Switzerland, so what happens is that you don't send the data using AT&T or other internet providers which are there. You actually use our internet and send it across. So that means that we maintain all the links, the routers, the infrastructure for the network for science. And this way we can guarantee the service being delivered to the scientists. So we have like a very large network. It's been there for 30 years. It was also part of the original ARPANET when the internet was starting 30, 40 years ago. So that's why we have an internet which spans from Europe all the way to the US, and we also connect to different US labs and universities across the world. So our mission is to support DOE sciences. So we work with physicists and different biologists and etc., and we provide the network services to them. And our other part is that we make it easy for the scientists, so they don't actually have to worry about networks. So we write tools which can easily allow them to configure the network for their science applications. So what is happening is that over the years, science networks are breaking boundaries. So not only is science happening within labs, like with these massive facilities which we have, we are seeing these kind of challenges where data rate is increasing, basically because the hardware is changing. We're going into FPGAs now, where the latency is much more reduced. Then we're also going into 5G and talking about 6G as well, where we will have a very high throughput and low latency and those kind of applications coming in. So there are new challenges coming in from the networking side. And we're also talking about virtual reality and augmented reality also coming in. There is also an edge evolution happening right now. FPGAs are being advanced at the edge, and basically machine learning is driving all of this because you want to do more and more machine learning at the edge. So we're looking at how we can actually optimize an end-to-end of an experiment. So what we are right now is the fixed telecoms network. So we're very good at what we do. So we have these high-performance computing grids across the US, and we connect them with very high-speed networks. So we do peering, HPC connectivity, etc. So we're talking about latency and range in these kilometers in milliseconds or 40 milliseconds. What we want to do is we want to move into this new space of wireless mobile networks where we change the latency and range, and then again going into edge devices. And we've started looking at 5G. DOE traditionally never did wireless research. So the second DOE use case is one which we already have currently running. So this is where the biologists are trying to create a digital twin for their experiments in the field. So what they're doing is that they are setting up sensors in Colorado, and a colleague of mine is involved in working on this. They're setting up these sensors in Colorado, and they are using CBRS systems to actually start collecting the data into our software, which is now running on high-performance computing grids. So this way, they can create digital models of the real world, and then they can do experiments in the digital world so that they can see how the real world would react. Now, from the biologist point of view, they would have their own research challenges, which they are exploring. From our point of view as network researchers, we have to make sure that the sensors are connected at all times. There is no downtime in the data which is coming in, and also the speed of the data which is connected. So because we have our own fiber, eventually we want the data to come onto the fiber as quickly as possible, because then we can guarantee the QoS. And eventually what we want to see is, so our team is trying to build this 5G orchestration middleware. So going off of this self-driving idea which we had, where we want to do AI at the middle, So what we want to do is build an adaptable middleware that whenever a new 5G starts up, it kind of like reconfigures itself and automatically connects to ESNet so that the software can do this and the scientists don't have to worry about it. So we started this research with simulations. The only 5G simulation out there was 5G Lena, which we started experimenting with. And the way we were doing is to see what are the optimum positions of certain sensors to be at for better throughput and minimum packet loss, because we have to guarantee the QoS of the networking provider. So this is what we're doing now, is because I mentioned this is the first time we're doing wireless research. We're actually building our own test bed for this, which we're calling Tower over here. So to give an example, like a diagrammatic representation of how this works is, so you can start from the left here where you see all of these edge devices connected to a UE element. That eventually connects to a base station, and then that brings into RAN controllers, which we are also looking into very heavily, which eventually connects to our 5G core. And then the idea is that the 5G core is going to connect to our wide area network, which is the Ethernet, Ethernet network, which we're talking about, because we have our own controllers. So we want to connect the 5G core to our controllers. And then once you're into our WAN, it's very easy for us to connect to other WANs as well. So other WANs could be AT&T, could be other research networks. So next slide here. This brings me to this slide. So we started this research last year, and we were held up by the supply chain issue as well. So we just got everything delivered in December. Basically, we ordered everything in February, March, and things took 9 months to get delivered. So things we've started it is with Raspberry Pis with 5G hats. So these come as antennas, which you can basically put in a Raspberry Pi inside it. And then you could connect those sensors into the Raspberry Pi and use that hat to do connections. Then we're also working on our own programmable SIM cards, which we can also put into these 5G hats so that they can connect to our network. And then Firecell also had this very interesting use cases of working with universities and different research labs, like Ignacio described. So we wanted to learn from the community as well. So there were a few reasons why we ended up choosing Firecell, and this is which is still being set up. So hopefully we get some hardware results. It's February now, so we're trying to get things done soon.